In this lecture, we're going to see the difference between a const pointer and a pointer to const. Or in other words, we're going to see different ways in which the const keyword can be applied to a pointer. And this can be really confusing, especially for beginners. So we're going to break this into little pieces that are really to understand, and I hope you're going to understand this. Here you see we have two variables. One is an integer var, the other is an integer other var. And we have a pointer called pvar. It's a pointer to int, and now it is pointing to int var, whose value is 22. This pointer is not a const pointer, and it is not pointing to something const. So there are a few things we can do with this pointer. One is we can go through pvar and modify this 22 here, for example, and make it a 55. We can do that because this pointer is not a pointer to const. We can go through it and modify the value pointed to by this pointer. That's what we mean here. The other thing we can do is change this pvar and make it point somewhere else. Now it is pointing to 1008, but it is possible to make it point to 1012. And we can do that. And we're going to see how we can do that once we get to try this in Visual Studio Code. I just want to get the concepts straight here. Okay, this is one kind of pointers that we can set up to point to our data. A non-const pointer to non-const. I should complete that. It's a non-const pointer to non-const because it points to something that is non-const. Or another way to say this is that we can go through this pointer and modify the data pointed to. And I want this to be super clear. The const keyword that we apply to our pointer here has nothing to do with the const keyword that we can apply to this variable here. Okay, so if we say it is a pointer to const, we mean that we can't go through this pointer to change what is pointed to. We don't really have to say const int here. Even if this is a regular int and we say this is a pointer to const, we can't go through this pointer and modify the data in here. And I realize this can be confusing to beginners, but we're going to make this clear once we get to play with this in Visual Studio Code. So bear with me here. The other kind of pointer we can have is a pointer to const. A pointer that we can't go through to modify the data pointed to. And the syntax to do that is here const int pointer. And once you have a pointer like this, you can't go through it and, for example, modify var here to be another value, for example, a 50 or a 55. You can't do that. If you're trying to do that, you're going to get a compiler error because this is a pointer to const. But this pointer is not a const pointer. In that, we can make it point somewhere else. For example, we can make it point to another variable, and it's no longer going to be pointing to 1008. For example, we can make it point to 1016 here. The compiler is going to allow us to do that. This is the second kind of pointer we can have. The other one we can have is a const pointer. And this is a pointer we can't make point somewhere else. And the syntax for that is here. You see that it is int star const. This can be really confusing, but I am going to show you a way you can summarize this and really keep this straight. But here you see that the const keyword shows up after the star symbol here. This is a sign that this is a const pointer. And a const pointer can't be made to point somewhere else. For example, right now we are pointing to 1008. If we try and make it point to 1012, we're going to get a compiler error because this kind of pointer doesn't do something like that. It's a const pointer and it only points to one location. And if you try and make it point somewhere else, you're going to get a compiler error. This is another kind of pointer we can have, but we have a few more. We can also have a const pointer to const. The const pointer part of it says that you can't make it point somewhere else, but the to const part of it says that we can't go through it and modify the data that is pointed to. And the syntax is here, const int star const. This is how you say it. And you have to remember these syntaxes. If you use them a little while, you're going to remember them. So don't really worry too much about that. Okay, now if you try and go through pvar and try to change the value in here, for example, make it a 55, you're going to get a compiler error. If you also try to make this pointer point somewhere else, you're going to get a compiler error because this is a const pointer. So this is a const pointer to const. We can also have a const pointer to something that is not const. This pointer can't be made point somewhere else because it is a const pointer, but we can go through it and modify the data that we are pointing to. For example, if we go through it and change var here to a 55, it's going to work. Now, I was trying to explain the concepts here. Now let's look at a few snippets of code to really try and drive the point home here. Here we have a row variable. It is int number. The value is 5 that we have inside. This variable is not const, so we can modify it. For example, we can change the 5 to a 12. We can even compound, add to it, and the value inside is going to change. If we print it out, we're going to see the value. We can even print its address here using the address of operator here. This is going to work. Now, we can set up a pointer to point to an integer variable. Here we have p number 1, which is an int pointer, and this pointer is a non-const pointer to non-const data. So the pointer itself is not const, and it is not pointing to something const. We initialize it with null pointer, and we're going to make it point to number 1 in this statement here. And we can do those two things we can do with pointers. We can go through it and modify the data pointed to. So if we dereference p number 1 and assign a value to that, the value is going to be stored inside. This is going to pass through the compiler. This is legal C++ code. But you can also make the pointer point somewhere else. For example, if we set up another variable called number 2, we can take the address of number 2 and assign that to p number 1, and this is going to effectively make p number 1 point to another location. And we can do that because this is not a const pointer. Here is another example in which we have a pointer to const. And we say our pointer is pointer to const with a syntax like this. We say const int star. We give it a variable name and we can assign it where it can point. In this case, it is pointing to number 3 here because we passed in the address of number 3. Now, this is a pointer to const. What that means is that we can't go through it and modify the data pointed to. If we try to do that, you see we dereference here and we try to assign a 444. If we do this, we're going to get a compiler error, but this is not a const pointer, so we can make it point somewhere else. And if we set up another variable, for example, this number 4 here containing 872, we can make p number 3 point to this new location, and this is not going to be a compiler error. So to be complete, this is a non-const pointer to const. One thing I want to make super clear is that the const keyword applies to a variable name. For example, here I have a variable called protected var. It is an integer, it's not const, so we can change the value inside. And we set up another variable, which is a pointer, and it's going to point to this protected variable. So we can't go through this pointer to change this variable because this is a const pointer. But the constness of this pointer has nothing to do with the constness of this protected variable here. They are two separate things. The const here is going to be protecting the p protected variable name here, and it has nothing to do with the constness of the protected var here. I really hope this makes sense. So if we try and dereference the pointer and try to change the value inside, we're going to get a compiler error, but we can use this variable and change what is inside. And this is going to work. And I really want you to make these things really clear in your mind. But if you have a variable that is const, for example here, some data is const int, and we try to set up a non-const pointer to that variable, we're going to get a compiler error. And the compiler is going to be right because we could go through this pointer and modify this data, violating the constness of this piece of data here. Because if I say it's const int, I don't expect it to change, but you could change it through this pointer. That's why the compiler stops you from doing something like this. So this is something you need to be aware of. Constant pointer mixed up can be really confusing, so that's why I do recommend, if you find this lecture confusing, do watch it a couple of times, and if you still have problems, do ask me. I will do the best I can to help you out. Okay, another thing we can do is set up a const pointer to const data, And this is really interesting. If you look at the syntax here, we have a const int star const, and this is how you say it. The const in front is saying that it is a pointer to const, and the const after the star is saying that it is a const pointer. Okay, so try to remember this syntax here, and we make it point to a const variable, which is called number 5 here. So this is going to be really interesting because we can't go through p number 5 and modify the data pointed to. If you try to do that, you're going to get a compiler error. You see here, this is a compiler error. But we can't also make this pointer point somewhere else. So if we set up another variable, for example, number 6 here, and we try and take the address of number 6 and assign that to p number 5, we're going to get a compiler error because this is a const pointer and we can't make it point somewhere else. The last thing I'm going to show you is that we can also have a const pointer to non-const data. And what this means is that we can't make the pointer point somewhere else, but we can go through the pointer and change the data that we are pointing to. And here is a simple example to that. We have a variable called number 7. It is an integer. And we have a const pointer to int variable called p number 7. Notice that the const appears to the right of this star symbol. So this says that this is a const pointer to int. We assign it the address of number 7. Because this is a const pointer, we can't make it point somewhere else, but we can go through the pointer and change the value pointed to. So if we do star p number 7 and assign a 456 to it, this is going to work. But if we try and make the pointer point to number 8 here, we're going to get a compiler error. Here is a simple reference that I put together to help you keep these things straight in your mind. Here we have a variable. It is an integer. It's called var1. Inside we have a 33. We can have a non-const pointer to int. And this is what pvar2 here is. We can go through this pointer to change the value pointed to, and we can make this pointer point somewhere else. This is a non-const pointer to int. And the syntax is int pointer. This is really simple. We can also have a pointer to const. And the syntax is const int star. And you see that const appears on the left of the star. This is saying that this is a pointer to const, and we can't go through it to modify the value that we are pointing to, but we can make it point somewhere else because it is not a const pointer. Okay. Let's go down and look at const int star const here. This is a const pointer to const. So we can't make it point somewhere else, and we can't go through the pointer to change the value pointed to. And the syntax is really this. We have a const on the left of the star, and we have another const to the right of the star. The one on the left says that this is a pointer to const. The one to the right says that this is a const pointer. And last but not least, we have a const pointer to non-const. So the const appears to the right of the star. So this is a const pointer, but it is not a pointer to const. So what this means is that we can go through p number 7 and change the value pointed to, but we can't make this pointer point somewhere else. And as a general guideline, you see here, if const shows up on the left of the star, the data is const. The data pointed to is const, I should say. If const shows up on the right of the star, the pointer itself is const, and we can't make it point somewhere else. This is really all I can say about this topic here. Now we're going to head over to Visual Studio Code and play with this in code. Okay, here we are in our working directory. The current project is const pointer and pointer to const. And we're going to grab our template files. So let's copy those and put the files in. And we're going to open this in Visual Studio Code. So open folder. The first thing we're going to do is set up a row variable that we can play with. So we're going to have number 5 here. It's not constant, so we can change number to any value we want. We can change it to a 12, for example. We can increment it and we can print it out. This is really simple. And we can print its address through the address of operator here. We can bring up a terminal to see this running. And we're going to build this. Let's build with GCC like we always do. The build is going to go through successfully, and we're going to clear and run rooster. and we're going to get our variable here. So we have number 5, its address is going to be this address here. We can change it to a 12 and add a 7. We're going to get a 19 and print that here, but the address of it is not going to change. This is not hard to understand. We can comment this out and show you that you can do stuff with pointers. The next thing we're going to do is set up a non-const pointer to non-const. Let's do that. I am going to put in the code and bring this down so that we have a better chance of seeing a lot of things here, and close the pane on the left here. Let's go through the code. We have a variable called p_1. It is a pointer to int. And we have another variable which is a raw integer, and the value inside is a 23. We can assign the address of number 1 to our pointer, and p_1 now is going to be pointing to number 1 here. So we can do a couple of things. For example, we can print the value in p_1. This is going to give us an address because it is a pointer. So it's going to print an address. If we dereference p_1 like this, we're going to print the value in the variable that is pointed to by our pointer. So we're going to print 23 here. And again, if we print number 1, we're going to get 23 because we are going directly through the variable. This is really easy to understand. And now we can change the value pointed to through the pointer. And we're going to do that here. And this is going to work because our pointer is not pointing to const, so we can go through it to modify stuff. And if we print data, we're going to see that the data has changed, and we're going to see a 432 printed out here. Down here, we're going to see that we can change the pointer itself and make it point somewhere else. We have a variable called number 2 here, and we're going to make the pointer point to number 2. Now, if we try to print stuff here, we're going to see that p_1 is now pointing to number 2. And if we dereference this guy, it's going to print a 56 here. We're going to run the code and go through it together. So let's bring this up. And we're going to build with GCC. The build is going to go through as usual. And we're going to clear and run rooster. And we're going to look at the output here. So we bring up the code so that we can see things happening. The first thing we say is pointer and value pointed to, both modifiable. That's what to say here. And we print the address of p_1. What is contained in this pointer, that's what we're going to print. This is the address. We're going to dereference it. It's going to print our 23. And if we go through the variable directly, we're going to get this 23 here. We are going to go down here and say that we are changing the value pointed to by the pointer through the pointer. That's what we're doing here. And if we print, you see that the value changes to 432, but the address of the variable hasn't changed. We are just changing the value inside. And this is something you should keep in mind and make sure you understand. Down here, we're going to change the pointer and make it point somewhere else. If we do that, the address here should change because the pointer should be pointing to a different address. And we do that here. We set up a new variable called number 2. We're going to make our pointer point to it by assigning the address of that variable to our pointer. And if we print p_1, now it's going to be pointing to another address different from the one we had before. But if we dereference p_1, we're going to get the value inside. We're going to get the 56 because now we are pointing to number 2 here. If we print number 1 and number 2, we're going to get the values that we had in those two variables. So this is really not anything new. And this is what this code does. Hopefully you can see that because this is a non-const pointer to non-const data, we can go through it to change the data pointed to, and we can make it point somewhere else like we did here. This is what I want you to see. We're going to comment this out and see another example. The next thing I want you to see is that we can also set up a pointer to const. And that's going to be a pointer through which we can go to modify the data that we are pointing to. So here we have a variable called number 3. This is the value inside. And we set up a pointer to const. And this is the syntax we saw in the slides. Const is showing up on the left of the store. So this is a pointer to const. We are initializing this guy with the address of number 3. So what this says is that we can't go through this pointer to modify the value inside the number 3 here. If we do that, we're going to get a compiler error. So let's uncomment this line here to show you that we get the compiler error. We should get a squiggly line from Visual Studio Code, and we see that here. If we try to compile this, we're going to get the expected compiler error because we can't really do that. This is a pointer to const, so we can't go through it to modify the data that we are pointing to, so this is not going to work. But we can make this pointer point somewhere else because it is not a const pointer. Okay, it is a pointer to const, but it is not a const pointer itself. So what we're going to do, we're going to set up a new variable called number 4. We're going to assign the address of this variable to p number 3, and we're going to try and print things out. We're going to see that the pointer now is pointing here, and if we try to dereference and print, we're going to get this value here printed out, 872. Now that we have this commented out, we can try and build with GCC. The build is going to be good, so we're going to clear this here, and we're going to run and see what we get. So what do we have here? We have pointer is modifiable. This is not going to change anything because the line here is not really working. But if we go down and say changing the address pointed to by p number 3 here, we're going to see that the address has changed. It was this address here. Now it is this new address that ends in DE0. And if we print the value inside through dereferencing like this, we're going to get 872 instead of the 632 that we had in before here. I hope this makes sense. So this is a pointer to const, but it is not a const pointer. Try to keep these concepts straight in your brain, and you're going to be glad you did that because you're going to meet these concepts a lot in your career as a C++ developer. So let's comment this out because we still have a few things we need to see. The next thing I want you to keep clear in your mind is that the const keyword applies to the variable name. And what do I mean here? Here we have a variable called protected var. It is an integer. Inside we have a 10. And we have a pointer, which is going to be a pointer to const. And the variable is called p protected var. It is a pointer to this p protected var. That's what I wanted to say here. And we initialize our pointer with the address of this variable. The fact that this is a pointer to const doesn't really mean that this variable here has to be const for this to take effect. This pointer being a pointer to const, we can't really go through it and modify this variable even if this variable itself is not const. So the constness of this pointer applies to this variable name of this pointer here. That's what I mean. So if you try and go through the pointer and modify protected var, you're going to get a compiler error. You're going to see that we're going to get a few squiggly lines here. This is what we mean. If you try and compile, you're going to get a compiler error. But even if the pointer is pointer to const, the variable itself is not const. So we can go through the variable name here and modify the data. And if we print, we're going to get this 66 reflected in here. Let's try and compile this. We're going to do that with GCC as usual. The build is going to go through and we're going to clear and run rooster. You're going to see that we no longer have a 10 in here because we have modified that with this assignment to our protected variable. I hope this drives the point home that the constness of the pointer itself has nothing to do with the constness of the data that we are pointing to, and that's what we really mean here. But be careful. If you have a variable that is const and try to set up a pointer that is not a pointer to const, the compiler is going to stop you from doing that and you're going to get a compiler error. We are going to see an example of that here. So here we have a variable, it is const, and we say that the variable name is some data. We put a 55 inside. If we try and set up a pointer that is not a pointer to const and initialize that with our variable here, which is const itself, we're going to get a compiler error because the compiler thinks we are trying to modify the constness of this variable. The person or the developer who set up this variable, they don't want it to be changed, and you are trying to set up a pointer that can be used to modify that variable through dereferencing like this. So the compiler is going to stop you from doing that, and it really makes sense. So this is something you need to be aware of, and we just looked at an example of that here. We are going to comment all this out because we still have a few things to cover. Next, we're going to see how we can set up a const pointer to const, and we can do that through a crazy syntax like we see here. We can say const and star const, and the const on the left of the star is going to mean that this is a pointer to const. The const on the right of the star sign is going to say that this is a const pointer. So if we try and go through this pointer and modify the data pointed to, we're going to get a compiler error. So this is an example here. If we uncomment this, you're going to see that Visual Studio Code is going to complain immediately. You don't want to do this. And if you try to compile, you're going to get the same compiler error. So this is the compiler error. So we don't want to do this because this says a pointer to const, but it is also a const pointer. So we can't really make it point somewhere else. If we do that, like we are doing here, Visual Studio Code is going to complain, and we're going to see the problem here. And if we try to compile, we're going to get a compiler error, which is going to be super clear about our scene. We're trying to assign to a read-only location, and that's not allowed. We're going to get a compiler error. And this is really how a const pointer to const is supposed to work. We're going to comment this out and look at a few more examples. The last thing we're going to see is that we can set up a const pointer to non-const. And the syntax is this. Again, the const is going to show up to the right of the star sign because this is a const pointer, but it is not a pointer to const. So we can go through it to modify what is pointed to, but we can't make it point somewhere else. So here we have an example. We can go through it to modify the pointed to value, and the compiler is going to be happy because this is not a pointer to const, but it is a const pointer. If we try and make it point somewhere else like we do down here, we're going to wait for Visual Studio Code to complain. You see we have a few squiggly lines, and if we compile this, we're going to get our trusty compiler error. Let's try and compile with Visual Studio Code, or GCC I should say. We're going to get our compiler error, and this is something we shouldn't do, and we're going to comment this out again. And this is really all we set out to do in this lecture. We saw a few combinations you can do on const and pointers. I realized that this can be confusing to many beginners. That's why I set up this general reference you can use to keep these things straight. Again, if the pointer itself is const, const is going to show up to the right of the star. If it is a pointer to const, the const is going to show up to the left of the star, and you can combine these things to achieve whatever it is you are after in your application. This is really all we set out to do in this lecture. I hope you found it interesting. In the next lecture, we're going to learn about arrays of const pointer to const char. Go ahead and finish up here and meet me there.